Hi, for this video, I want to discuss the property, the difference of two squares. Basically, what's going to happen with this is sometimes you will have to factor and sometimes you will have to multiply it out. So I'm going to go ahead and do both of them. But this is one of those rules that you want to recognize because it shows up a lot in factoring problems. This is something that will show up in all algebraic levels of math. So like if you're talking about pre-algebra, algebra 1, algebra 2, college algebra, it also shows up in trig and calculus. So it's one of those things that if you recognize this and know it always, it will help you out throughout your math courses. So whether you're starting out or you've been doing this for a while, just make sure that you understand this rule. Okay, the reason why a squared minus b squared factors into a plus b times a minus b, if we took and FOILed a plus b times a minus b, we can see that the first times the first gives me a squared, and then the first times the last gives me negative ab. Then when I go to the inside, I get BA, which is the same thing as AB. It's best just to write it alphabetically. It just appears better, so that way you can see that they're the same thing. And b times negative b gives you negative b squared. So what happens is when you're multiplying these, because this one is positive and this one is negative, your middle terms always cancel each other out, and so you're left with the a squared minus b squared. So instead of having to go through and show all the work, if you know the shortcut, it can save you time. It's really important that you can recognize this when it comes to factoring, because problems like this will show up. So I'm going to start with an easy one. Basically, what's happening here is we can obviously see that our first term is x squared. Well, this term right here is 6 squared. So 6 squared gives me 36, and it has to be separated by subtraction. That's why it's called the difference of two squares. The difference is the answer to a subtraction problem. So anytime you have subtraction, if it was addition, this rule would not work. Okay, so what we do is we just try to figure out what number is being squared, so we can see that x is our value that is being squared for the first term. So I would write that first. And then 6 is the value that is being squared to get the 36. And then all I have to do is make one positive, make one negative, and that's it. Okay, for this next one, it's a little bit harder to see just because of the fact that we complicated it a little bit more, but we still have the same thing. For our first one, we really have 5x squared. For this one, we really have 7y squared. So it's no different. We just now replace the a and the b with the 5x and the 7y. So we would just say 5x plus 7y and 5x minus 7y. Okay, so anytime you see a perfect square that is separated by subtraction, this rule will apply. I wanted to throw one in here because this is like one of those special things that sometimes you just need to be able to recognize. So we can see that this first part here is x squared, and this one here ends up giving me 4 squared. So when I separate this, I have x squared minus 4. And I can just put the plus just to stay consistent. It doesn't matter whether you put plus or minus first, but just to stay consistent with what I've written. We would have x squared minus 4. Well, you need to be able to recognize that again, we have another one that follows a difference of two squares, because now we have x squared and we have 2 squared. Okay, this one can't break down because it's positive, so we would leave it as x squared plus 4. This one we would break down into x plus 2 and x minus 2. So this would be the fully factored answer for this one. Okay, so you do need to be able to recognize that sometimes you can use the difference of two squares a second time. Okay, so these last ones, you could always FOIL if you forget the rule, but I'm going to use the rule. So remember that if you have the same thing in both of them, the only difference is one is positive, one is negative, then the middle terms are always going to cancel each other out. So I would just square my first term, which would be x. square my second term, which is 121, and because I'm doing a negative times a positive, it would be negative. Like I said, if you FOILed this out, the 11x minus 11x would cancel out, so you would end up with the same thing, it's just more work. And for this last one, we would do 3y times 3y, which is 9y squared. Because these are opposite signs, the negative 12y and the positive 12y would cancel out, so we just don't need them. So all we have to write is 9y squared minus 16, because 4 times negative 4 is negative 16. So with this, like I said, this is a property that will show up quite often in courses that involve algebra. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you would like me to cover, please let me know that as well.